Good morning. Hats off, electronic device put away, cell phones in your cell pockets. Don't you feel like you're right back in the classroom again? Unfortunately, it doesn't look like we're going to be there for a little while, so we'll have to rely on this format to pass on information. Please know that you will be taking notes on this presentation. I know you don't have your notebook, but you can certainly add it to your notebook when you get back to school. So today's discussion is on alternate views. In some cases, the orthographic projection, that would be the front, top, right side, are not enough to get all the dimensions in that you need. So we rely on other types of views like section views, auxiliary views, and detail views. The section views provide a cutaway of the object. They use a cutting plane like you see here. There's our cutting plane that goes across like that. That cutting plane basically says, if we were to cut that right off, right across there, this is what we would be able to see. Now, the nice thing about being able to see all this, we could also dimension all that. And the section lines are these little diagonal lines that go through here. A little bit difficult to see on this particular one, but there's section lines that go right through there. And this cutting plane line is a heavier, thicker line, probably the heaviest line on your drawings. You can see that it goes long dash, two short dash, long dash, two short dash, and the arrows represent what is being kept. I'm just pointing out the section lines. There are three types of section views: full section, half section, and offset section. The cutting plane passes fully through the entire object. That would be a full section, although we realized once we cut through it, we're removing half of it away. So this full section, you're going to actually see half of it. In this case over here on the left, you'll notice that the cutting plane crosses through this circular object. And you'll notice that we're going to cut away this part. And what do we see? We see the right side. Now look how much detail is in this right side. There are a lot of hidden lines over here that we wouldn't be able to dimension normally on just from a normal right side. But with this, where all these little section lines, that's how much they cut away. And look at all the dimensions we can add because they're no longer hidden lines. As we know, rule number 1, never, ever, ever dimension to a hidden line. Half sections used on symmetrical parts, right? Basically, 1/4 of it would be cut away. Once again, we're looking at a cylinder shape. This is an isometric view with that half section taken out of there. If you're looking at it from this particular view, which they said was the front, the cutting plane comes across like that. It would come directly down and out, removing just this corner. And if you look over here on the right, you'll see the right side looks like a normal right side, whereas the lower part of the right side would be the section. You can see the section views. What part did we use a section or a half section on our train? That would be the axle peg. The axle peg, we actually did a half section in Inventor. There's your cutting plane lines. They also include a offset section. We don't use them a whole lot, but know that they are there. This is where the cutting plane line cuts across one section, drops back through the object, cuts another section out, and then another section out. What's nice about that is you're going to be able to see the depth of all those blind holes. And you can see how much of the diagonal section lines are here. Auxiliary view is another type of alternate view. We used an auxiliary view on one of our train parts, and that would be the cow catcher. The cow catcher had an inclined plane on the very front. And the only way to see the true size and shape of that inclined plane would be to do what we call an auxiliary view. It's foreshortened. So if I look at the front here, or I look at the right side, this surface is never seen true size and shape. It's called foreshortened. This diagonal on the top, you can see the diagonal edge right there. To create the full true size and shape of that diagonal surface, you'd have to create what we call a auxiliary view coming right straight out, and you can see the circle, and you could dimension the circle location and all that other stuff. So this is the true size and shape of that particular diagonal plane. A detailed view is just an enlargement of a small part of the entire drawing. So if you look on the detail, I was showing a couple of people as we were starting to do some of the detail work on various objects that we were working on in Inventor. Inventor does it very easily. You just simply click on detail, you pick where you want it, it draws a little circle around it, and then you can create an enlargement of that to whatever scale you want, in this case 2:1, anywhere on your drawing. It doesn't have to line up with the front, the top, the right side, it doesn't have to line up with any of them, which is kind of nice. So that's going to be what we call a detail drawing. And that concludes alternate views. Alternate views, once again, are all the views that are included in the, we have section views, we have auxiliary views, and we have detail views. All of these things are at your disposal as you are trying to actually put all the dimensions in where you need them as we start to work on a reverse engineering project. With that, as you know, and as I put out in an email, our reverse engineering project has been suspended. We will not be working on that until we return from this break, so don't worry about it. I suppose if you have Inventor at home and you have access to your drawings and you want to keep working on them, obviously I have no problem with that, but know that when we get back, we're going to have at least 5 days to get that project done, to complete that project. So now that we've learned about alternate views, it's time to try them out. If you go back under our Google Classroom page, you'll find this activity, activity 7.2, section views. I'd say you pick it up from the windowsill, but that's not going to happen today. So just essentially open. I would say download. I have it in Word format, and I'm going to try to put it in a PDF format for those of you that are there, whichever you like. If you would be more, if you'd be happy with the Google Docs format, I guess I could switch it over to that too, but you just have to let me know whichever format works best for you. In this first activity, pretty straightforward. They want you to create a section view from, they have the top, they have the right side, and you can see that the cutting plane lines cutting right through the center of it. Use your projection lines. So the front view is going to end up being your section view. No, you can project the heights from the right side, you can project the widths from the top. And use those projection lines, and don't forget about putting the section view lines in after you're done. Same thing's true for this particular one, where you're going to use the top view and the right side view to create a section view, but this time the section view goes right through the center on the right side. I guess it wouldn't matter if it was on the top or on the right side, it's going to show up pretty much the same. Now here we have a half section where they cut this corner away right here. This one's probably easier than the first two because what you're going to see is basically the right side and then the right side with it cut away. So remember, in a circular type of view, you'll find that they are pretty much the same views, right? That's why we typically, for a number of cylinder-shaped type of objects, we'll only create two views, top and maybe the front. So in this case, they did a section view to show you the inside of it. Don't forget to put in your section lines. And then last but not least, we have number 4, where you're going to take this drawing. You're going to get some grid paper. It could be some of the paper that I posted on our Google Classroom, which is our normal Pinkerton grid paper, or you can just use a piece of graph paper anywhere. And you're going to lay this out using the measurements that they have here, which can be challenging. Do the best you can. Obviously, you're just going to have a ruler to work with. They want you to create a section view of this object. And I would say, by looking at it, this section view is going to go right through the center so that we get this hole, we get that hole, we get this cut out. So the section view is going to go right through the center. Got a couple of conclusionary questions, and that would be it. What I ask that you do is to scan all these pages and submit them or upload them to our Google Classroom page, and I'll be checking those off. This type of activity is going to be extensive, so I would say it would be a 2 2-day project, a 2-day session. So I would not expect it to be done, and probably I'll update it anyway. But if our class is scheduled on Thursday and Monday, so I would say by the end of the day on Monday, you would have this done. So it's going to be covered in two classes. But I'll keep updating you on that information. All right. If you have any questions, obviously, just shoot me an email, and I'll be happy to respond. Have a good day.